In this video, I want to show that this infinite series with the expression n to the third plus 3 dividing by 2 to the n, that this infinite series converges to 29. First, I need to show that the series, the infinite series with the expression n dividing by 2 to the n, and n starts at 2, and that this series converges to 3/2. So when n is 2, we get 2 over 4. When n is 3, we get 3 over 8. And then when n is 4, we get 4 over 16, and so on. So let's call this sum right here infinite sum. Let's call it S. And now multiply S by 2. Two times 2 over 4 is 1. 2 times 3 over 8 is 3 over 4. And then 2 times 4 over 16 is 4 over 8. And so on. 2s minus s. And so we get 1 3/4 minus 2/4, 4/8 minus 3/8, and so on. 2s minus s is s, and then here we get 1/4, 1/8, 1/16, and so on. So this is the sum. We can rewrite this part right here as summation of with the expression 1 over 2 to the n. When n is 2, we get 1/4. When n is 3, we get 1/8. When n is 4, we get 1 over 16, and so on. And then 1 over 2 to the n, and we can rewrite it as 1/2 to the n. And then this summation right here, this is a geometric series with the first term of 1/4 and a common ratio of 1/2. So we know it converges to a over 1 minus r. So a is the value of the first term, which is 1/4, and then 1 minus the common ratio of 1/2. So we end up with 1/2. And so the this part is 1/2, and so we get 1 plus 1/2 is 3/2. And therefore the sum with the expression, the infinite series with the expression 2 to the n dividing by 2 to the n, n starts at 2. This sum, this infinite series here converges to 3/2. And then next, I need to show that the infinite series with the expression n to the n squared dividing by 2 to the n, n starts at 2, and that this infinite series converges to 11/2. When n is 2, we get 4 over 4. When n is 3, we get 9 over 8. When n is 4, we get 16 over 16, and so on. So again, let this sum right here, call it S, multiply by 2. This is 1. 2 times 1 is 2. 2 times 9 over 8 is 9 over 4. And then 2 times 16 over 16 is 16 over 8, and so on. 2s minus s, so it would be this sum minus this sum. So we get 2, and then 9/4 minus 4/4. 16/8 minus 9/8 25 over 16 minus 16 over 16, and so on. Right here we get 5, and then here we get 7, and then here we get 9, and then here we get 11, and here we get 13. This is this is 5, 7, 9, 11, 13, so we can rewrite this as 2n plus 1. The summation with the 2n plus 1 over 2 to the n. Again, right here, when n is 2, we get 5, and we get 4. When n is 3, we get 7, and we get 8, and so on. And then for this summation, we can rewrite this as the summation of with the 2n over 2 to the n, and then plus 1 over 2 to the n. And then this part is the same as 2 times n over 2 to the n. N starts at 2, and this is the geometric series with the first term of 1/4 and common ratio of 1/2. And so this part will get 1/2. And then this summation right here, a few moments ago, we have shown that is equal to 3/2. And so right here we get 2 times 3/2, and then plus 1/2. So 2 plus 1/2 is 5/2, and then 2 times 3/2 right here. And so the whole thing will be 11/2. So far, I've shown that the infinite series with the expression n over 2 to the n, it starts at 2, and I've just shown that this is equal to 3/2. And then I've just also shown that the infinite series with the expression n squared dividing by 2 to the n, n starts at 2, and I've just shown that this series here converges to 11/2. And then before we can get to the series that we want down here, the infinite series, we need to show one more result. And now I want to show that the series with the expression n to the third over 2 to the n starts at 1. And I need to show that this is equal to 26. When n is 1, we get 1/2. When n is 2, we get 8 over 4. When n is 3, we get 27 over 8. And so on. Let's call this sum right here, call it S. Multiply both sides by 2. We have 2S. 2 times 1/2 is 1. 2 times 8 over 4 is 8 over 2. 2 times 27 over 8 is 27 over 4, and so on. 2s minus s, so it would be this sum minus this sum. We get 1 a/2 minus 1/2. 27 over 4 minus 8 over 4. 64 over 8 minus 27 over 8, and so on. A minus 1 is 7. 27 minus 8 is 19. 64 minus 27 is 37. 125 minus 64 is 61, and so on. And then the sequence 1, 7, 19, 37, 61, 91, and so on. And this is known as the sequence of hexagonal numbers. And the formula for this sequence here is 3n squared minus 3n plus 1. N starts at 1. So when n is 1, we get 1. When n is 2, we get 7. When n is 3, we get 19, and so on. And so now we can write this sum right here as 1 plus the summation of 3n squared minus 3n plus 1 dividing by 2 to the n minus 1. When n is 2, we get 7, and then here we get 2. When n is 3, we get 19, and then here we get 4. When n is 4, we get 37. And then down here we get 8, and so on. And now let's rewrite this sum right here as 3n squared dividing by 2 to the n times 2 to the n minus 1. Because 2 to the n minus 1, we can rewrite it as 2 to the n times 2 to the negative 1. And then plus negative 3n dividing by 2 to the n times 2 to the minus 2 to the negative 1. And then plus 1 over 2 to the n times 2 to the negative 1. This is 3 dividing by 2 to the negative 1 minus 3 dividing by 2 to the negative 1, and then 1 dividing by 2 to the negative 1. This would be 6, this would be 6, and this would be 2. And then 1 over 2 to the n is the same as 1/2 to the n. And then once again, this summation right here, summation with the expression 1/2 to the n, this is a geometric series, and it converges to 1/2. So this part right here is 1/2. And then this part we have shown earlier that this is 11/2, and then earlier we have shown that this is 3/2. And so the whole thing we get for the altogether we get 26. So the summation with the expression n to the third over 2 to the n is 26. And so far I've shown that this series with n over 2 to the n is 3/2, and then the series with n squared over 2 to the n is 11/2, and I've just shown that the series with the n to the third over 2 to the n, this is 26. And then now let's show that this series here is 29. And so the series with n to the third plus 3 over 2 to the n, we can rewrite it as series summation of n to the third over 2 to the n plus 3 summation with the expression 3 over 2 to the n. And then this part right here, this is the same as 3 times 1 over 2 to the n, summation of 1 over 2 to the n. And then 1 over 2 to the n is the same as 1/2 to the n. And again, we have shown earlier that this is a geometric series with 8 equal to 1/2, and r is also equal to 1/2. And so this part here converges to 1. And then I have just shown that this infinite series right here, this is 26. So this infinite series 26. So 26 plus 3 times 1 is 29. And that's the end of the video.